Alrighty, so last week of the quarter and last week of the school year, and for some of you, last week of Clark. Congratulations on making it all the way to the end. This CS sequence in particular, 224, 23, and 215, is a somewhat daunting sequence. I mean, we cover a lot of stuff, even without the shortened term and the online aspect. It's a challenging set of courses to begin with, but I think people are in excellent shape, and I've graded PA5 and given feedback where I could on that. And PA5, I think people did a fantastic job with. I'm guessing most people felt that this assignment was perhaps more challenging than some of the other ones, and that was by design, right? I really kind of intended to raise the bar on this one for a few reasons. One, because I feel like people this year in this course sequence could totally handle it, right? I've just seen a lot of growth and where people are, and had good confidence that people would be able to do an assignment like this, and it turns out that was justified. I mean, people were successful in this, and it's a larger scale project. It's a project that takes a number of different things that you've done and asks you to put them together in a way that leads to something bigger than the sum of its parts. And that's one of the essences of programming, and the results were great, right? So pretty much everybody who had code that would compile and run was able to get the graphical parts working, get the connection set up, manage the user interaction to establish a connection, decide who's server and client, and so on. And then do the basic gameplay, share information between the two elements, and use that to play out a game, and that's just awesome. Let me talk about some of the things that I saw people running into, and some of the ways to address those. And if you have any questions or comments along the way, definitely shout them out or put them in chat. So first of all, the easy things, right? So a number of people did not name the class correctly. Okay, it's supposed to be called net dot, and some people called it net dots, some called it dots, some called it dots, right? A number of people did not put their name in their code. And a number of people did not do things like setting the initial server name to be server, or the default server name to be server, and the default host to be localhost, and things like that. And I'm okay with that, because if those are the most common problems I'm seeing, that's fantastic, because those things are all really easy to remedy, right? Just always put your name in your code, always put comments in your code, always make sure that if it's supposed to be called blah, you call it blah, and so on. Those are things I did not take off points for, okay, but I have to leave you with a warning that as you go on to other courses, those things can be the difference between getting an A and getting a 0, right? I know situations where you don't name the class correctly and you've got a 0. Or you submit your code and you forgot one piece of it, like an include file, and the program won't compile and you get a 0. Okay? And if you've got 4 assignments in a course and you get a 0 on one of them, you've gone from potentially getting an A to wondering if you're going to pass the course, right? And if you're in a semester system and you fail a course, it's going to put you back a year. So these are simple things, but they're really important. And I've taken off for these in the past to try to, help nudge people into believing that these are important. But I didn't ding on PA5. because I was mostly excited by, you know, the fact that people did such a good job with the programming part of it and getting this to work, which is really, you know, what it's about. But I wanted to mention, you know, make sure you submit all the pieces you need to compile, and test your final submitted code by downloading it and recompiling it and making sure that it still compiles and so on. All right, so let's talk about coding itself. Let's talk about PA5 in particular and coding in general. And so one set of issues that I saw people running into boils down to kind of where things are done. So for example, let's imagine, you know, two people playing the game of dots. Those are hard to see, but don't worry about it. You can imagine they're there. And you know, one player comes over and they click right here, and so it draws a line. And it may be that the other player doesn't see that line until they click somewhere. And when they click up here, that line gets drawn, and the other player's line suddenly appears. And the first player doesn't see that second player's line until they click somewhere. And then suddenly it draws that second player's line, but the second player hasn't seen this newly drawn line. And I saw things like that in some people's code. If something like that is happening, like, what's the problem? It could be that you're not calling repaint in the right spot. And if you want to know if that's the issue, an easy way to check is, you know, when you're in this situation where this line should have been drawn over here, just go grab the corner of that with your mouse and resize the window a little bit. Because when you resize a window, repaint gets called. And if that line suddenly appears, now you know it's a question of calling repaint. And you can call repaint more than once, right? Anytime you do something that you think might make it interesting to redraw the display, you can call repaint. Okay? But it does take resources. Don't just make an infinite loop that calls repaint forever, because that'll slow things down. But, you know, if resizing the window does not make that line appear, then what does that mean? Well, it might mean that, you know, the coordinates of this new mouse click have not been sent to the other player. Or it might mean that the thread that receives these coordinates has processed these but not done something with these XY coordinates yet. Maybe they got saved in variables somewhere, and something will happen when this player clicks the mouse that will use those saved variables to draw a line. Right? So throw in some print statements. Right? When you draw this line here and you think you're sending XY coordinates, put a print message in there saying, I just sent the XY coordinates. And over here in your thread that's reading from the socket, when you read a pair of coordinates, make a print message. I just read, you know, X comma Y. And now, you know, click this line over here and see what's happening. If it's not getting sent, right, that tells you you have to change something in that mouse code. If it is getting sent and you're receiving it, but this line isn't being drawn, take a look at what you're doing after you receive those coordinates. Are they being saved somewhere to be processed later, or are you processing them right now? Another thing is sometimes the order of operations. So it may be that for something to happen, you need to do steps A and B in that order. And maybe something happens and you do step A and step B, but maybe something occurs in between here that should have occurred before you did A. And so you do A, and then this thing happens and you do B, but that doesn't actually take this into account because this is processed in step A. And so the next time you do A, B, suddenly this thing is now affecting the behavior of your program. And so if you had a situation where, for example, you had to click twice for something to happen, it may be something like this, where maybe you should have waited until after this thing happens and then done A and B, or maybe some part of A should have been done in B, or something like that, right? So how do we figure out these things? These programs are big, right? Several hundred lines of code for a lot of people's PA5. That's a lot of parts and pieces. Some of this code was written by us, some of it was written by Window Builder. Some of it was taken from our PA4. So lots of different pieces of code coming into play here. And how do you figure out what's going on? Well, it can be tricky. But what I can suggest is some ways to make it easier to answer that question. Some ways to perhaps better manage your code base, so that when you want to figure out, why isn't this happening until this other thing occurs, that you may be more successful at finding the answer. And so let's talk about variables. So a lot of people discovered statics. And we do public static void main. And I said I wouldn't talk about statics for a long time, and then eventually I talked about them, and I basically said never use statics. But a lot of people discovered statics, okay? If you Google statics in Java, you'll usually find it in the context of evil statics, right? Statics are a way that you can implement global variables in Java. And no, global variables aren't necessarily evil. I mean, at the machine language level, everything is global, right? Because you just have main memory. But using global variables can lead to a lot of pitfalls, okay? It can lead to sloppiness in your code, where you just have a variable called player1 score, and anybody who wants to read it just reads this variable. Anyone who wants to update it just updates this variable, right? Which works fine in a perfect world, but suppose you're developing your code with somebody else, and suppose you're making a change to player1 score, and some other piece of code doesn't know that this variable has changed, and has saved a copy of the value of player1 score, and is using that for something, and is unaware that score has changed. Or suppose you have a piece of code with a local variable named player1 score, right? Somebody's writing code and they want to do something with that, and now when they try to get to player1 score, right, they're using their local copy instead of the global copy, right? Or vice versa. So the idea is, when we're dealing with objects in an object-oriented framework, we have code, we have methods for doing things, and these interact with, certain pieces of data. And those are bound together into an object. And here we have some other piece of code and some other set of data, and those are bound together in an object. And if you just made everything global, you have a very different picture. You have a whole set of code, and you have a whole set of variables. And this is one thing, and this is another thing. And there's no natural association with this piece of data goes with this method and this method, right? It's just a bunch of functions and a bunch of data. Okay, this is a little more C-like, and this is very much assembly language-like. If you've done 270, right, you make all your file registers. They're not associated with any particular piece of your code. It's just kind of, this code uses this file register, that code uses that file register. And that's part of what makes it confusing and error-prone. So in an object-oriented mindset, right, we have the code and the data that code processes, and they're bound together. And it really is kind of contrary to this idea of making a static where this thing is accessible to everything just by saying class name dot variable name. Okay. Now, one place where you are allowed to use statics without getting disapproving looks from your coworkers is if you say final static. That's how you can define a constant. And the final keyword says I'm going to declare a variable with a value, and that value will not change. It cannot be changed. So if I said final static int box size equals 50, and this is inside like my box class, then anywhere in my code that I want to know the box size, I can say name of the class dot box size, and I'm going to get 50. And that's usually considered to be okay because I can't change this, right? Since this is declared to be a 50 up here in the declaration of that variable, anybody who's using this variable can rightfully expect that they're going to get the number 50. It's really like a pound define in C. It's just a way to declare a magic number without hardwiring that magic number everywhere in your code. Because if every time I need to use the box size I have to have a 50 in my code, and I'm going to draw a rectangle that's 50-50, and I'm going to go to 25-25 to draw my initial, and so on. If I make this a variable, right, even though it doesn't vary, I can draw my rectangle with the width and height of this, and I can draw my initial at this divided by 2 from the edge, and so on and so forth. And then if I decide I want bigger boxes, I can just change this to 100 and recompile. But other than that, I would really stay away from static variables. Okay? In general, stay away from globals. And so there's a few reasons for that. A few we've already mentioned, right? Code maintenance, developing things in groups, unit testing, stuff like that. And just sort of, that it gets away from sort of the spirit and the mindset of object-oriented design. But it's also just plain more error prone. So let's think about player one score. Okay, let's think about whose turn it is, right? So let's say integer turn equals 1, and let's say this can be a 1 or a 2 for player 1 or player 2. Or you could call it, server client or AB or whatever. But, let's say you have some variable that keeps track of whose turn it is, right? And I don't know where I declare this. I declare it somewhere. Lots of things are going to want to access this variable, okay? For example, when you click the mouse, you need to know, is it your turn or not? If it's not, you should, ignore that mouse click. When you go through your array of boxes and you find a newly completed box and you have to put an initial in it, you need to know whose turn it is. So you know whether to put player 1's initial or player 2's initial. When you receive coordinates from the socket, you might want to know whose turn is it and make sure it's actually the other player's turn before you process those coordinates. That would stop somebody from hacking their program and taking multiple turns in between your turn. You didn't have to do that, but you could do that. The cutthroat world of net dots can be like that. So lots of different pieces of code are going to want access to this turn variable. On the other hand, not too many things update this. Right? So when does the turn really change? Or potentially change? After somebody has clicked and you've gone through and you've looked to see if a box has been completed. So if whoever's turn it is takes their turn and no box has been completed, now the turn changes to the other player. Otherwise it stays where it is. So looking at this, I would say it gets updated in one place, it gets read from multiple places. One thing you can do is, every place that's going to want to know whose turn it is can keep a copy of a variable called turn. And you can try to keep that in sync. Every time that the turn changes, you go through and you update all of those. That's just begging for bugs, right? It's cleaner to have this stored in one spot, preferably close to where it's going to be modified, and then let other people access it, other methods. Okay, and this is where we would start getting into information hiding, making things private, and then using an accessor to let other methods access this variable. So maybe in my mouse click code, I would translate the mouse click into XY coordinates, and I would figure out if a line got drawn, and then I would go through and I'd see if a box was completed, and then after all that, I might say turn equals something, right? But the other time the turn will change is when I get in my thread a socketed message saying the other players click the mouse, and then I'm going to do the same kind of thing, and if a box wasn't completed, I'll change the turn. So maybe, all of this stuff gets bundled into a method, which I was calling just click. And so my mouse listener would call click XY. The thread that's getting a mouse information from the other player would call click XY. And if this one method is responsible for figuring out if a box was completed and then updating the turn, now I've got a single point where this variable is being updated. And if I make a function called, whose turn, which simply returns the value of that variable, now I've got a nice encapsulated object-oriented management of my turn system. All right. Let's extend this to the notion of well, and where would we put this ideally, right? So I could put it right here because this is the only place that takes care of it. Something else I could do is I could make a new class for managing the actual board. Remember, we have this array of boxes. It's an 8x8, and we have some object in there that might be called board, and that's the set of 8 boxes, and each box has booleans for top and bottom and left and right, and maybe a string for who owns the box. And so let's think about this click code, right? You've got a series of boxes, boom, 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 a series of lines, and I just click the mouse right here. And so I find the row and the column, and it's this box up here, and I find the closest edge, which is here, and I set that to be true. And remember, we said go to the box next to you and set the corresponding edge there to be true. And now I have to check 2 boxes to see if the box has been completed, because it's possible I completed this box, but it's also possible I completed the box 1 row lower. Because I clicked on the bottom of this region, I also clicked on the top of this region, so I also need to go into this box and check the top and see if that was not clicked before, and if now this whole box is completely filled in, and if it is, then I need to see whose turn it is, set their initials, right, and remember that it's still going to be this player's turn. Well, here's a case where we could take a totally different approach. Because we have this array of boxes, and each box tells us which edges have lines drawn, and also tells us who owns the box. So click the mouse, find the row column, find the closest edge, and update your booleans accordingly. Don't do anything with the who. Just update the booleans, so that after the mouse click, I know that I have this 2-dimensional array of boxes where the booleans tell me where I have edges. Okay, I can take that array and I can pass it to a totally independent method that knows nothing about mouse clicks and nothing about whose turn it is, but simply does the following. Go through each box in this array, and if all 4 of these are set and the box is listed as not owned by anybody, guess what? Somebody just completed a box. And I can make a function called, did somebody just complete a box? And it can do exactly that. It can go through all 64 boxes, see if all 4 edges are set and who is equal to blank, and if it is, return true. And if it doesn't find such a box, return false. And so now I can say if somebody completed a turn, then don't change the turn, otherwise set turn equal to the other player. I can make another method called mark boxes, and I can tell it whose turn it is, and it can go through, and anywhere it finds a box where all 4 edges have been completed and the box is unowned, it will set it to the initial of whichever player I told it. And I would pass the turn information to that method, right? I could ask it to pull it out of some sort of global or to call some function to find out whose turn it is, but if I want that method to know whose turn it is, I'm going to pass it as an argument. Right? So this is the other reason why we avoid globals, because we don't need them. Because if we're going to run a piece of code that needs access to a particular variable and we have access to it, we can give it to that method. Right? And that's nice and clean. That lets us write this method, it lets us test this method by passing these different values to it and so on and so forth, as opposed to relying on the existence of some other variable that is going to read from some object defined from some class somewhere, And I could choose to make a new class. Maybe I would call it, field of dots or something like that. And that object would contain the playing board and a method for seeing if somebody completed a box and a method for updating the initials in the boxes. And I could also make a method for getting the player 1 score and a method for getting the player 2 score. If you have the array of boxes, how do you find player 1 score? Go through and look for, a box where who is equal to player 1's initial. Count up how many of those you have, that's player 1's score. Same with player 2. I could make a method in there called is the game over? And what do? I go through and I look for any boxes where who has not been set. If there's at least one box that hasn't been claimed by someone, the game's not over. If all of them have been claimed, the game is over. And now I've got this whole class called, field of boxes, or whatever I called it. And all the stuff I need to interact with my game is housed in that class. And if I have an object of that type, right, I can use that to access this information. And so we're trying to avoid redundancy. We're trying to avoid, having multiple copies of a player's score. And in fact, we never need to have a copy of the player's score anywhere. We can make a method that counts how many boxes are owned by a player, gives us the score. And now all we need to maintain the integrity of is these booleans in this array of boxes. So those are just some ideas to think about. I've mentioned before that in this assignment in particular, it's not uncommon to write it and get partway through or maybe all the way through, and then suddenly say, I really should have done such and such. I really should have put my array of boxes into a separate class. I really should have updated the booleans in my mouse handler. I should have had my thread constructed in this place instead of that place, right? And if you go back, you might find yourself completely redesigning your program, right? That's not a bad thing. Other than the realities of time and deadlines, but in terms of thinking about how to organize more complex code, right? Sometimes you get partway through a project and it's like, yeah, this is really a mess. I really need to redo this. And that's okay. That's a good thing, right? I do that all the time. Because you don't really understand the structure of your system until you're developing it. And then you can see oh, wait a minute, this really belongs with that, I started trying to make a system to transcribe basketball games, and keep track of what's going on in the game. So you can go back later and generate statistics from this data. And partway through, you know, I was tracking players and I was tracking penalties and all this kind of stuff. And partway through, I realized all I had to track was the ball. And if I knew what the ball was doing, whose hands it was in, who it was going to, was it going into a basket, and so on, everything else came from that, right? And there was a major rewrite point for the whole thing because I had a different perspective after having worked with it for a while. This happens a lot, right? So if you want to, you know, if you feel like your PA5 code, you got it to work, but you don't feel really great about it, and you want to think about, you know, how could I have done this in a way that felt better, it's not a bad project to go back and rework it, right? Maybe take a break from it for a few days, but see if you can find a different way to do it. I got office hours all week, by the way, so if you want to talk about your PA5, if you want to screen share code and kick around ideas, totally happy to do that. So I just want to toss that out there for what it might be worth to anyone. So anyway, punchline, really good job on PA5, right? These are not criticisms. These are things to think about, right, for down the road. All right, so let me know if you have any questions or comments or concerns on any of that stuff. All right, so let's go on to other stuff. So I want to start talking about the URL class in Java. URL is a class that's under JavaNet that lets us interact with URLs, universal resource locators. So what's the web? I mean, we use this all the time. We don't necessarily talk about it. I don't know why I get like stuff on here. I guess because I'm using Firefox. So you know, you go to a website like Astronomy Picture of the Day, and you get stuff, right? That shows up here. And what we're really doing is we're querying a server somewhere to give us a page, right? A set of information. And this thing up here, which we call a URL address, right? This is how we specify what it is we're looking for. So apod.nasa.gov is an address, right? It's a host name, and this is a directory on that host, and this is a file in that directory. And HTTPS is a protocol. It's saying, you know, what are we after here? We're after a hypertext page. And when we put in this request to this server and the server responds, it sends us this. Okay, so Control U on a page gets you the source code. This is what's actually being sent to us. It's a bunch of text. And there's no magic in here, right? But our browser, Firefox in this case, when it sees a document like this, it will interpret it and make it look like that. Now if I go to linuxengrcs.com, ~nix shared 223, right, I get something very different. I get a directory listing. And here's a file.java, and if I click on that, what do I see? Oh. Okay, that's fine. No, this is Firefox. You ruined my punchline, man. All right, so if I click on a file like, you know, testprogram.java, what do I see? I see the source code for that file, right? If I do a Control U to look at the source, it's exactly the same thing. Okay, so when this is sent by the web server that I connected to, my browser just displays it as, you know, a bunch of characters. Okay, but if instead the server sends me this, right, my browser interprets it like that. And this, you know, could be stored in a file, astropix.html, or it could be generated on the fly. It could be that when I go to a page, a piece of code is running on the server, and the output of that code is all of this stuff. Or it could be that the output of the code is stuff that my browser will execute, like JavaScript, and will cause something different to appear on this page. Okay, but the underlying mechanism for all of this is a URL, a Universal Resource Locator. And so there's a URL class available in Java, and it can be constructed with a simple string, right, which creates a URL object. And it turns out we can interact with this in a way that lets us basically look at web pages from Java code. And so let me start this off here, and we'll continue it tomorrow. But I'm going to construct a URL object, and then I'm going to use this open stream to get an input stream associated with the object. And once we have an input stream, we can create a scanner, and we can read from that scanner and get some information. So let's make a project. So we'll call this NASA, and let's make a JFrame. Yeah, I'll just do a regular class. Do a public static main. Yeah, we'll call it main. So we'll say URL, I'll call this page equals new URL. And we'll just go off astronomy picture of the day.nasa.gov. Okay, so we'll import our URL class, and this is all going to have to go in a try-catch block. So I'll do that. And again, I'll be lazy and I'll put all my code in a single try-catch block, because nobody's grading this, so I can get away with it. All right, so we've got our URL called page. So let's open a stream. So open stream is going to return an object of type input stream. So I'm going to say input stream. I'll just call it is equals page.openStream. And I'll have to import input stream, and I'll import it from java.io. There's other packages I can import it from. And then let's make a scanner, not a scammer. We'll construct a scanner on that input stream, and we'll import that. And let's just read from it. So we'll call next line. And we'll just print this out. All right, and I should probably close my scanner when I'm done, just to get rid of the squiggly line under there. All right, so just exploratory code. Okay, we'll open a URL on this page, get an input stream, use that to build a scanner, and then we'll just read from the scanner as long as stuff is available. And let's watch what this does. So I'll go ahead and run it, and what did I get? I got a bunch of HTML, which looks suspiciously like this. All right, so I can read this stuff directly from Java by just opening a connection using URL and then working that into a scanner and reading from it in the usual way. So we can read these web pages using this approach. And there's other ways we could do this. We could make a socketed connection to the port that the web server is listening to, and we could send a GET message to say, you know, fetch this page and send it back to me. But we need to understand the language of, you know, requesting pages, and we need to deal with security issues and getting an encrypted page and so on and so forth. And the URL class bundles all of that for us. And let's just say, give me an input stream, and start reading from it. All right, so we can grab stuff from web pages really easily like this. All right, but we'll build on this tomorrow, and we'll actually turn this into a web browser and see how easy it is to take all of this and turn it into something like that. And it's really easy in Java because there are classes that will do all the hard work for us, that will interpret this hypertext properly to give us a nice web page. So we'll play with that tomorrow. We'll see how to add some other bells and whistles to it and so on and so forth. We'll have a lot of fun with that. And then I'll spend a little bit of time talking about Android. We'll just kind of go through a start to finish Android development example just to see sort of the parallels with doing GUI development under Swing and Window Builder. And then I want to take a little bit of time to look at some source code for Java and just kind of get an idea of some of that stuff, because that's fun to see. And then we'll pretty much do some review for the exam, and that'll be it. It'll be Friday. All right, so thank you for the SLP reports. If you turned those in already, I've started grading those. And don't forget to turn in your video presentation link by the deadline, which is tomorrow afternoon. And then you're done with submissions until, you know, the final exam. So cool. All right. Have a great rest of the afternoon. I'll be in office hours at 3, and I will see you next time. Bye.